there are three different types of average or instantaneous velocity problem. The first type is they give you a table value and then they ask you a bunch of questions. And then the second type is a graph. And then the third type, which is what I think the best, is they give you a function and then they put that on an application problem and then they ask you a bunch of questions, including some average and instantaneous velocity problem regarding that function. So let's do the first type. The first type is table value. So let's say we have a table. So we have a t, and then this is the time, and then this is xt. And then for time, I didn't use any actual number. I will just use t1, t2, t3 to t5. So just make this like how do you take care of that in general. So for each t, you plug it into the function, but they didn't give you the function, then you have x of t1. Just think about this as x value and y value, right? And then they ask you for an average velocity problem. So let's say finding the average velocity, the time interval is between t2 and t5. So what you have to do is you just have to follow the formula. So average velocity, that is just like finding the slope of a straight line, so which is y2 minus y1 divided by x2 minus x1. That is equals to x of t5 minus x of t2. So y2 minus y1 divided by x2 minus x1, t5 minus t2. So that is the first type. All you have to do is you grab 2 points and then you subtract them. And then the next type is they give you a graph. So they give you a graph. They didn't give you a table, but that is the same thing as giving you some table value, except they graph all the values for you. So this one we have a graph. So the t is the time, and then the x is the distance traveled at time t, and then for each time there is a distance. So let's say you want to find the average velocity. So let's write this. So average velocity, and then the time interval. How about time is between 2 and 6? So how do you take care of that? So this one you will be using just finding the slope of a straight line. So what do I mean by that? So from 2 to 6, right? So this is a 2, this is a 6. You draw a straight line to connect them, and then you do the rise over run stuff. So this is just like finding the slope of a straight line. So like that. So the run is 6 minus 2, and then the rise is that 29? Yep, so 29 minus 20. So that is just like the slope of this straight line. Okay, and then the top we have a 29 minus 20. The bottom we have a 6 minus 2. So this one, the 29 and a 20, I didn't give you, did I say the distance travel? So let's say the distance is in feet, okay? Is feet, meter, whatever you like to use. So that is equals to 9 and then over 4, right? So let's say this is in feet and then this is in seconds. So the line over 4 is feet per second. Feet per second, not second. So let's change that to feet per second. Okay, so that's how you do it. And then the next type is the one that I like the most, because you put that in applications, calculus, right? You are going to take some classes for science. You'll be taking classes in science and engineering. So other than dealing with the math, you have to know what to do when people put that on an application problem. So this is an application problem we would like to discuss. You throw a ball into the air from the roof of a building. So time, t is the time in second, and then the y stands for the distance above the ground, and then here is your function. So you have y equals to f of t, that is equals to negative 20t squared plus 60t plus 80. So this is second degree, right? So second degree quadratic function. So second degree means this is a parabola, and then this leading coefficient, negative 20 is negative. That means the parabola is facing down. So we have a parabola facing down. So the parabola is going to go like this. Okay. And then the first question is you find the initial height, and then you find the average velocity of the first 5 seconds. All right. Let's go. A is finding the initial height. So that means at the very beginning, right? So A is initial height. I'll just initial height is when time equals to 0, then you have f of 0 that is equals to -20, 0 squared plus 60, 0, and then plus 80. So you have 80 feet. So at the very beginning, the ball is 80 feet above the ground. And then the average velocity, so average velocity, the time interval is between the first 5 seconds. Okay, so that will be between 0 and a 5. So average velocity, that will be using f of 5, right? Minus f of 0. I know the function is a parabola, but for average velocity, all you have to do is you draw a straight line to connect these 2 points, and then you find the slope of that straight line. So when x is equals to 5, so this is just 5 minus 0. So when x is equals to 5, then you have to do this. So f of 5 that equals to -25 squared plus 65 plus 80. I already did the math, so this is I have 119.97, so 97,998. And then hold on. Okay, you know what? I just copied this wrong from my notes. Just look at the wrong place. I will just give you the answer. This one I have a -200 divided by 5. Okay, so -200 divided by 5. So -200 divided by 5. So that is equals to -40. Unit is important. That's in feet per second, because this is in feet, this is in seconds. So put them together, then you have feet per second. Okay. What does that mean? So that for velocity, you have to define the direction. Velocity can be positive or negative, but speed must be either 0 or positive. So let's say for when the ball is going up, then you have a positive velocity. So you throw a ball, right? So you throw a ball at the very beginning, throw a ball, the ball will go all the way up and then reach to the top and then drops down to the ground. So the velocity will just go up, up, and then you will reach to the top and then it will go down. So when the ball is going down, we define that as negative velocity. Okay, but for the first 5 seconds, you might say, hey, when x is equals to, when t is equals to 0, when t is equals to 0, we have positive, right? Because at the very beginning, you have to throw the ball up, right? Because the ball is not going to drop straight down when the ball lift your hand. You are throwing the ball straight up, so the ball should go up and then go down. But here is the thing. So for every second, so t between 0 and 5, right? So t between 0 and 5, I will think about that like this. T between 0 and 5. So t can be 0, 0.1, 0.2, something like 1.2, 1.6, 2.44, and then so on and so forth, all the way reach to 5. So every time you plug in a t, you get a different height, right? The idea of average velocity is you are taking an average. How about this? Let's make this even easier. You are taking 5 exams, okay? You are taking 5 exams, so you will have 5 scores. Let's say you did well on the first 2, but you get a 0 on the rest. So overall, if you consider all 5 scores overall, do you think you did a great job when you take an average? So good score number 1, good score number 2, and then 3, 4, 5, all bad, all 0. So overall, when you add them up, divided by 5, do you think you will end up with a good average score? The answer is no, right? So this one, I will be thinking this as from 0 to 5, the average velocity is -40 feet per second. So that means like on average, the ball is going down. So on average, if you consider this interval as an average, as like one item, the ball is going down. Just like when you consider the 5 scores, the average is bad. So in my perspective, in an instructor's perspective, you didn't do well on exams. Okay. All right, so that is B. So how about C? C is the instantaneous velocity. Instantaneous velocity. So I want to know what is the velocity of the ball when t is at 2 seconds. So when t is equals to 2. So what happened when t is equals to 2? So at that moment, if you take a picture at that moment, the ball is motionless. But using what I just taught, instantaneous velocity. How do you find instantaneous velocity? So for instantaneous velocity, we need to know what happened when t equals to 2, and then I will just make a little step forward, right? So the idea is, let's switch to a different color. So for C, instantaneous velocity at t equals to 2, right? So when t equals to 2, we have a point, right? So what we have to do is we have to add a little h to it. So let's say we have to make one little step forward. So let's say t equals to 2.001. Do we agree that these 2 points are very, very close? Because you only add one little bit of h forward. And then we would let h goes to 0, right? We will let h goes to 0. Now, if you do not use any limit, just use plus, minus, and division. So here is what you have to do. You are going to draw a straight line to connect these 2 points, and then you will just find the average velocity. Yes, you're right. You will connect these 2 points using a straight line, but you are looking for the average, and then you will just find the average velocity. Then you might be saying, all right, instantaneous and average are not the same. So how about this? Let me ask you a very simple question. So let's say I am finding the average of 2 numbers, 5 and 5.0001. If you add them up and then divide it by 2, do we agree that the average is just 5, right? Because the other number, you just add a little bit amount to it. So when you take the average, the number will just equals to 5, right? So this one, same thing. I just add a little bit of h to the next point. So the average is just like the instantaneous velocity, right? Because I just add a little bit to it. But if you add a lot to the next t, then I'm sorry, that is not a good approximation. Okay, so let's go. Then we will using the slope of a straight line, y2 minus y1, x2 minus x1. So that will be f of 2.001 minus f of 2. So that is y2 minus y1, and then x2 minus x1. This one, you plug it in, you will get 119,97998 minus 120 divided by 0.001. So that is equals to negative 20.02 feet per second. Okay, now what about the method using a limit? What do I mean the method using a limit? So do you still remember this? This function describes where the ball is, right? So let me copy it and then paste this over. This function describes where the ball is. When t is equals to 0, that means the ball is still on your hand, right? When t is equals to 0, y is equals to 80. So that means initially the ball is 80 feet above the ground, right? So this tells you the position. I'll just write, this tells you the position of the ball. Now, you are talking about average velocity, instantaneous velocity. So for instantaneous velocity, if you check the previous video, I chose many different h. And then I got many answers. And then at the end of the day, I said when h goes to 0, the instantaneous velocity is equals to such and such, right? So this one, when you make the t so small, I'm sure that the instantaneous velocity is approximately equals to 20. But what I am trying to say is, hey, so you have one function to describe the position. Now, can you find one function to describe the velocity at any point, then you don't have to plug in like this anymore, right? Just find one function to describe every single every single velocity at one single point. So we do not need y2 minus y1, this kind of thing, right? So what you have to do is you will have to do a limit as h goes to 0, and then f of x t plus h, so they use t plus h minus f of t divided by h, and then you will get to that. So this one you will be doing limit as h goes to 0, negative 20 t plus h squared plus 60 t plus h, and then plus 80 minus the given function minus 20t squared plus 60t plus 80, and then divided by h, so you must get rid of the h. So the math, I'm not going to show all the details, so all you have to do is you have to multiply everything out, and then eventually you will be able to cancel all the like terms, and then you will be able to factor 1h. Remember, you will be able to factor 1h to get rid of the h in the denominator. So as a result, you will get to negative 40 t plus 60. So this is one function to describe the velocity at time t. So if you say what is the velocity when time is equals to 2? So when the velocity when time equals to 2, so that is equals to negative 40 times 2, so that is equals to negative 80, and then minus 60 plus 60, so that is equals to negative 20 feet per second. So when t is equals to 5, all you have to do is just plug in. Okay, so that's it for the instantaneous velocity. And then what else did I ask? I asked what time the ball reached to the maximum. I'm looking at this spot. The ball reached to the maximum at time equals to what? And then the ball drops on the ground at time equals to what? That is a very interesting question. So let's copy the function one more time. So I'm going to copy the function one more time. And then this one, you will have to figure out the vertex. What part are we doing? We are doing part D. So for part D, you will have to figure out the vertex. You will have to figure out the vertex. This is an upside down parabola, right? This is at the maximum. You have to figure out the vertex. So the way we do this is we will do completing the square. So I factor a negative 20 out. So this is a t squared minus 3t minus 4. When I do complete the square, I want the coefficient of the t squared to be equals to 0. So inside the parenthesis, you have a quadratic expression, ax squared plus bx plus c, and c is equals to negative 3. So when you do complete the square, you have to do a b divided by 2 square. So that is a negative 3 divided by 2 square. Do not square this out. But if you have your own way to do complete the square, follow your own way. T squared minus 3t, and then you add this extra square. I know that changed the problem, but at the end of the day, I will subtract the same thing. Okay, and then you have a negative 20. So for this piece, I will bring the variable down, and then everything inside the parenthesis down, and then you push the 2 outside. You push the square outside. And then for the rest, you will add a 20 times whatever that is. So that is negative 4 minus 9 over 4. So this piece goes here. And then you have a negative 20 t minus 3 over 2 square. So overall that is equals to 125. Okay, so for a parabola, there is a vertex form. So vertex form of a parabola. So that is y equals to a times x minus h squared plus k, and then the vertex is at h comma k. A is negative, so a equals to negative 20, so that is negative. That means the function opens downward, like that is like an upside down parabola. And then what is your h? The h comma k, the h is equals to 3 over 2. K is equals to 125. So this is t, and then this is did I use feet? Yes. and then that is the position. So when t is equals to 3/2 seconds, the height is the maximum. So the ball is at maximum height, 125 feet above the ground. What else? The last thing, that goes for the next part. The next thing is when do the ball reach to the ground. So this is it for part D, and then the last part is part E. How long does it take for the ball to drop to the ground? So for part E, the height equals to 0, because at 0 the ball is on the ground, right? So the ball is on the ground means 0 feet above the ground. So you let y equals to 0, so you have a negative 20t squared plus 60t plus 80, and then you factor that, so 0 is equals to negative 20, and then you have t plus 1, and then you have a t minus 4, 0 product property, t is equals to negative 1, t is equals to 4. Of course, t cannot be equal to 1. We are talking about time. Time cannot be negative. So that tells me 4 seconds later, the ball will hit the ground. It takes 4 seconds for the ball to hit the ground. Okay, so that is the end of this video. If you like it, you think this explanation is helpful, give me a like, share the video for me. I will see you all in the next one. Signing out.